Hello everyone. In this video we will discuss continuity and differentiability. First let us see the definition of continuity. A function f of x is said to be continuous at x is equal to a if limit of f of x as extends to a minus, that is left hand limit, is equal to limit of f of x as extends to a plus, that is right hand limit, is equal to f of a, that is the value of the function. Otherwise we say that the function is discontinuous. If f of x and g of x are the two continuous functions at x is equal to a, then f plus g of x, that is sum of two continuous functions, and difference of two continuous functions, that is f minus g of x, and f into g of x, that is product of two continuous functions, and quotient of two continuous functions where g of a is not equal to 0 is continuous at x is equal to a. That is, the summary is, if left hand limit is equal to right hand limit is equal to the value of the function at that particular point, then we say that the function is continuous at x is equal to a. This is first definition. And then sum of or difference of or product of or quotient of two continuous function is again continuous. Now we will define the differentiability of a function. A function f of x is said to be differentiable at x is equal to a if left hand derivative at x equals a is equal to right hand derivative at x is equal to a. The left hand derivative is given by limit as h tends to 0 minus of f of a plus h minus f of a by h is equal to, the right hand derivative is limit as h tends to 0 plus of f of a plus h minus f of a by h, which is equal to f dash of a. This is the derivative of the function at the point a, that is limit as h tends to 0 of f of a plus h minus f of a by h is equal to f dash of a. This is the definition of differentiability of a function. We discussed the definition of continuity and differentiability. Now let us see some properties. There are three kinds of discontinuity. That is, if left hand limit and right hand limit both exist but not equal, that is left hand limit is not equal to right hand limit, then we say that the function is discontinuous. This kind of discontinuity is, this is discontinuity of first kind, and there is another type of discontinuity which is removable discontinuity. That is left hand limit and right hand limit both exist and equal but not equal to f of a. That is, left hand limit is equal to right hand limit, but this is not equal to f of a. So this is second kind of discontinuity. And third type of discontinuity is, so this is called as removable discontinuity. This is discontinuity of first kind. And second one what I discussed now is, this is called as removable discontinuity. Removable discontinuity, we will call this as removable discontinuity. And second kind of discontinuity is limit doesn't exist. So that is, if none of the limits, that is LHL or RHL, doesn't exist, then we say that function is discontinuous, and this is second kind of discontinuity. So there are three types of discontinuities now we discussed. Now we will make some important remarks. So constant function in the domain R is continuous. See, continuity of some of the common functions. See, the constant function over R is continuous. Identity function in the set of real numbers, and polynomial functions over set of real numbers, and rational functions, that is p of x by q of x, a function of the form where q of x is not equal to 0. P of x by q of x is a rational function which is the f of x. So this is also continuous, always it is continuous, and modulus function is also continuous, and x to the power of minus n, where n is positive, is continuous in the domain R minus 0, and all trigonometric functions, that is sin x, cos x, tan x, secant x, cot x, and cosecant x, all trigonometric functions are continuous, and exponential functions are continuous, and logarithmic functions and inverse trigonometric functions in its domain, and composite functions where f and g are continuous are also continuous. So these are some of the important remarks about the continuity of the functions. Now let us discuss some of the questions, that is multiple choice questions on continuity and differentiability. If f of x is equal to x to the power of 5 minus 32 by x minus 2 for x not equal to 2, and it is k for x is equal to 2 is continuous at x is equal to 2, then k is equal to 16, 80, 32 and 8. So to solve this question, let us use the definition of continuity of a function. So we have seen that is a limit of f of x as x tends to a will be equal to f of a. This is the definition of continuity. So that is left hand limit and right hand limit exists, and it is equal to the value of the function. Here it is given that the function is continuous at x is equal to 2. So the function to be continuous at x is equal to 2, we must have limit as x tends to 2 of x to the power of 5 minus 32 by x minus 2 is equal to f of 2, that is f of 2 is equal to k. So this implies we can rewrite this as limit as x tends to 2 of x to the power of 5 minus 32 can be written as 2 to the power of 5 divided by x minus 2, which is equal to k, that is f of 2 is k. Here it is given at x is equal to 2, the value of the function is k. So we have a formula which we have studied in the last year, that is in first PU, that is limit as x tends to a of x to the power of n minus a to the power of n by x minus a is equal to n a to the power of n minus 1. So we will apply this formula here, so that I have n is equal to 5 and a is equal to 2 in the given problem. So this implies k is equal to n a to the power of n minus 1. N is 5, a is 2 to the power of 5 minus 1, that is k is equal to 2 to the power of 4 is 16, 16 into 5 is 80. So option B is the right answer. So k is equal to 80. So for the function to be continuous, k must be equal to 80. So this is how we solve the problems on continuity. Now let us look at the second question. The point of discontinuity of f of x is equal to tan of pi x by x plus 1 other than x equals minus 1 or option A is x equals 2m minus 1 by 2m plus 1. Option B is x is equal to 2m plus 1 by 1 minus 2m, where m is any integer. And option C is x is equal to pi. And option D is x is equal to 0. The function f of x is discontinuous wherever it is not defined. You see, f is discontinuous wherever it is not defined. It is not defined. So let us put m is equal to 1. Put m is equal to 1 in option B. So then x will be equal to 2 into 1 plus 1 by 1 minus 2 into 1. So you can observe here, x is equal to 2m plus 1 by 1 minus 2m. I am putting x is equal to 1 here. So therefore we get x is equal to 2 plus 1, 2 into 1 plus 1 is 3 divided by minus 1, which is equal to minus 3. Now at x equals minus 3, f of x becomes, so that is f of minus 3 at x is equal to minus 3, f of x becomes, that is f of minus 3 is equal to tan of, you put x equals minus 3 there, so you will get minus 3 pi divided by minus 3 plus 1, which will be equal to tan of 3 pi by 2. So we know that tan theta is not defined for odd multiples of pi by 2. So tan of n pi by 2 is not defined whenever n is odd. So it's not defined means at x is equal to minus 3, the given function tan of pi x by x plus 1 is not defined. Wherever the function is not defined, the function is discontinuous. So therefore for x is equal to 2m plus 1 by 1 minus 2m, where m is any integer, the function is discontinuous. This is the conclusion. So I have taken m is equal to 1 in option B. So you can check with option A and option C and option D also. There it is clearly defined. See, if for x is equal to 0, it becomes tan 0, which is defined. And in the option A, if you put m is equal to 1, you will get 1 by 3. So x is equal to 1 by 3. For x equals 1 by 3, this is defined. So in this case, when you choose x is equal to 1 in this case, that is in option B, so we get odd multiple of pi by 2, that is the angle is an odd multiple of pi by 2 in f of x. So therefore it is discontinuous. Next, look at the next question. If the function f of x is equal to x square minus a plus 2 plus a by x minus 2 for x not equal to 2, and it is equal to 2 when x is equal to 2 is continuous at x equals to, it is given that this function is continuous. It's given that this function is continuous at x is equal to 2. Then a is equal to option A 1, option B 0 and minus 1, option C and option D is 3. So the task here is I have to find the value of a for which the given function is continuous. So we will use the same definition, that is the continuity, the definition of continuity. So we have limit of f of x, that is x square minus of a plus 2 plus a divided by x minus 2 as x tends to 2 is equal to f of 2, f of 2, which is equal to 2 actually. So we have a rule called as L'Hopital's rule. L'Hopital's rule. This rule can be applied to evaluate the limits when it takes either 0 by 0 form or infinity by infinity form. 0 by 0 or infinity by infinity form. That is, if the given limit is in this form, that is in indeterminate form, we can apply L'Hopital's rule. So it says that we can differentiate. This limit is equal to, the given limit will be equal to derivative of the numerator and denominator of the derivative of the denominator, and you can apply the same limit to that. So let us see how with this example only. That is, what I do is I will take this limit as x tends to 2 of, we will differentiate the numerator, that is 2x, derivative of x square is 2x, minus a plus 2 into x. Actually x is missing here in the given problem. X square minus a plus 2 into x plus a by x minus 2. So while typing this was missed, that's why I am writing this x here. I have considered this x. So we know that derivative of kx is k. So therefore it will be minus of a plus 2 and derivative of a is 0 whole divided by derivative of x minus 2 is 1, which is equal to f of 2 is 2. That is, when x is equal to 2, the value of the function is 2. So I am writing 2 here. So now you can apply the limit so that we can evaluate this value of a. Okay. So it is limit, when you apply this limit here, you will get 2 into 2 minus of a plus 2 is equal to 2 here. So it is 4 minus a minus 2 is equal to 2. So this implies that a is equal to 0. So 2, I have 4 minus 2 here, 4 minus 2 is 2, 2 cancels, and a is equal to 0. So for a is equal to 0, the given function is continuous at x is equal to 2. So this is the answer. So now we'll see one more problem. Actually it is tan inverse x here. I have tan inverse of x in the denominator. The value of f of 0, so that the function f of x is equal to 2x minus sin inverse x by 2x plus tan inverse x is continuous at each point of its domain. The value of f of 0, so that is, I have to find the value of f of 0 so that this given function is continuous at each point of its domain. So for continuity at x is equal to 0, we know that limit of f of x must be equal to the value of the function. See, for continuity, for any function to be continuous, so again we are using the definition so that it will be familiar to you. Limit of f of x as x tends to a must be equal to f of a. Here in each point of its domain, but value of f of 0 means at x is equal to 0. So I will consider limit as x tends to 0 of 2x minus sin inverse x divided by 2x plus tan inverse of x is equal to f of 0. So this is what is required to find, that is, I have to find f of 0. So now what I will do is I will divide both numerator and denominator by x. So we get limit as x tends to 0 of 2 minus sin inverse of x by x whole divided by 2 plus tan inverse of x by x is equal to f of 0. So you can recall which we learnt in first PU, limit as theta tends to 0 of sin theta by theta is equal to 1. Similarly, for inverse trigonometric function, sin inverse of x by x as x tends to 0 is 1, and tan inverse of x by x as x tends to 0 is also equal to 1. So therefore, so what we can do here is we will evaluate this limit like this: 2 minus 1 by 2 plus 1 is equal to f of 0. That is, the sin inverse of x by x is 1 and tan inverse of x by x is also 1. So hence 2 minus 1 by 2 plus 1, that is 2 minus 1 by 2 plus 1 here is f of 0. Upon simplification we get f of 0 as 1 by 3. So 1 by 3 is in option C. So option C is the right answer. So you can observe the question. F of x is given and it is given that it is continuous at the point 0. To be continuous at 0, I have to apply the definition. Limit of f of x as x tends to 0 is equal to f of 0. So all the problems are based on the continuity. And now we will discuss one more question. How should we define f of x is equal to log of 1 plus ax minus log of 1 minus bx by x at x equals 0, so as to make it continuous at x is equal to 0? A similar question based on the definition. So I will use the definition again. I have to take this limit as x tends to 0 of log of 1 plus ax minus log of 1 minus bx divided by x is equal to, the question is, so as to make it continuous at x is equal to 0, how should we define f of x? So I have to evaluate this problem, that is I have to find the value of f of 0. So again I will apply L'Hopital's rule. L'Hopital's rule to evaluate this, because when you put x is equal to 0, that is when x approaches to 0, the given problem will be log of 1 plus 0 minus log of 1 minus 0 will be 0 by 0. So it takes 0 by 0 form. So I can apply L'Hopital's rule. So now this will be limit as x tends to 0 of, I will differentiate log x. See, d by dx of log x is 1 by x. D by dx of log x is 1 by x, and there is a rule called as chain rule. Chain rule is, if you have log of something, it will be 1 by something into d by dx of something. So that is, if you have f of x to the power of f of x, I have to differentiate this as f dash of x into derivative of x. So this is called as chain rule. So log something is 1 by something into d by dx of something. So when you differentiate log of 1 plus ax, I will get 1 by 1 plus ax into derivative of 1 plus ax. Derivative of 1 is 0 and derivative of ax is a, minus log of 1 minus bx is 1 minus bx into derivative of 1 minus bx is minus b whole divided by derivative of x is 1. So we are not going to apply quotient rule here while differentiating in L'Hopital's rule. Just differentiate the numerator and just differentiate the denominator, so that you will get the answer. So here I have f of 0 on the right hand side. So now when x approaches to 0, you can notice this becomes ax, that is a into 0 is 0, and 1 into a. I will get a minus into minus plus b here. That is bx. It becomes 0 when x approaches to 0. So I will get a plus b is equal to f of 0. So I have a plus b as the answer, which is in option C. So option C is the right answer. So this is an application, a problem based on the application of L'Hopital's rule. So L'Hopital's rule is not discussed in NCERT textbook, but this is very helpful in solving the questions for CET and JEE examination. So whenever the limit takes the 0 by 0 or infinity by infinity, that is indeterminate form, so you can apply L'Hopital's rule. State which of the following statement is a false statement. I have to identify the false statement here. If f of x is continuous, f of x is continuous at x equals a, then f of a is equal to limit of f of x as x tends to a. See, actually this is the definition of continuity. So option A is correct answer. That is, option A is right, but it is not false. It's not wrong. It's the right definition. Limit of f of x as x tends to a is equal to f of a. If limit of f of x as x tends to a exists, if it exists, then f of x is continuous at x is equal to a. So we cannot say this because we know that I have discussed with you 3 types of discontinuity. If limit of f of x as x tends to a exists, but it is not equal to f of a, then it is a removable discontinuity. So here we cannot conclude that if f of x exists, then we can't say that it is continuous at x is equal to a. We have to see whether it is equal to f of a. So therefore this is the false statement. Clearly option B is the false statement. This is the required answer. We need not check with C and D, but we will see what this statement C says. If f of x is differentiable at x equals a, then it is continuous at x equals a. So this is the one of the property. Actually differentiability implies continuity. Differentiability implies continuity. That is, if the function is differentiable, then we can say that it is continuous, whereas converse is not true. The best example for this is modulus of x. Modulus of x is a continuous function, but it is not differentiable at x is equal to 0. So that is why if f of x is differentiable at x equals a, then it is continuous at x is equal to a is right. If f of x is continuous at x equals a, then limit of f of x as x tends to a exists. Of course, this implies this. If f of x is continuous, then we can say that it exists. So answer is option B. So clearly B is the right answer. Next, I have one more problem on the continuity. If f of x is equal to x into sine of 1 by x for x not equal to 0, 0 for x is equal to 0, then at x is equal to 0, the function is differentiable but not continuous, continuous but not differentiable, not continuous, and continuous and differentiable. So we have to write the correct answer here by solving this question. If f of x is equal to x into sine of 1 by x for x not equal to 0, and for x equals 0, it is 0 here. So let us consider the limits. Now limit of f of x as x tends to a is equal to f of a is the definition of continuity here. So now I will consider limit of this x into sine of 1 by x as x tends to 0. This is equal to as x approaches to 0, this x is 0 into, we know that sine is a value from -1 to +1. So it is a certain value. I have a certain value for sine of 1 by x. So 0 into a certain value is 0, and it is given that the value of the function at x is equal to 0 is 0. Therefore it is f of 0. So we can say that the function is continuous at x is equal to 0. Now I have to check for the differentiability of the given function. So clearly it is continuous now. In the options, option A says differentiable but not continuous, but the function is continuous, so option A is not correct. Continuous but not differentiable, and continuous and differentiable. So either answer is option B and option C, and option B or option D are the any one of these two will be the answer, because we have seen that the function is continuous. As I have to check for differentiability now, I will write the definition of derivability of a function at 0. F dash of 0 is limit as h tends to 0 of f of 0 plus h minus f of 0 by h is the definition of the derivability, that is differentiability. So now if we replace x by 0 plus h, so I will write like this. This f dash of 0 is limit as h tends to 0 of h into 0 plus h is sine of 1 by h minus f of 0. So we have seen that it is given that f of 0 is equal to 0, so therefore I can write it as 0 divided by h. So now h is eliminated. So as h approaches to 0 here, now this is infinity, that is as h approaches to 0, this limit does not exist, doesn't exist, because it will tend to an uncertain value. So there is no finite quantity when you apply the limit, so it is not differentiable. So option B is the right answer, continuous but not differentiable. So next question is let f of x is equal to sine of pi x by 5x for x not equal to 0 and k for x is equal to 0. If f of x is continuous at x equals 0, then the value of k is. So actually in board examination you can find a 4 marks problem like this in part E of the question paper. So it is very important type of problem, that is application of the definition of continuity here. So again the function is continuous. Function is continuous means limit of f of x as x approaches to a is f of a. So I will write limit of f of x as x approaches to a is equal to f of a. Here I have to check the continuity at 0. So limit as x tends to 0 of sine of pi x by 5x is equal to k. So let us use this limit as x tends to 0 of sin x by x is equal to 1 here. I have sin pi x, I should have sin pi x by pi x to make this as 1. So we will manipulate this. I will take this 5 outside because it is a constant. I will rewrite this as limit as x tends to 0 of sin pi x divided by, I write pi x, and I will multiply this by pi, so that value will not change. So now the term inside this bracket, this is the term rounded, is 1. The value is 1 by this theorem, limit as x tends to 0 of sin x by x is equal to 1. So now I have pi by 5. As this becomes 1, when we apply the limit, we get k is equal to pi by 5. Sorry, this is 1 by 5. On the right hand side I have k, so I will get this 1 by 5 into pi here, so pi into 5. Okay, actually there is a mistake while typing the options. Here it is pi by 5 in fact, so pi by 5 is the right answer. Option A is correct here. So we'll move to next question. The function f of x is equal to modulus of x plus modulus of x by x is discontinuous at the origin because mod x is discontinuous there, continuous at the origin, discontinuous at the origin because modulus of x and modulus of x by x is discontinuous there, discontinuous at the origin because modulus of x by x is discontinuous there. So you can read the question again. So there are 4 options. Given function is f of x is equal to modulus of x plus modulus of x by x. So I have to check whether it is discontinuous or continuous. Discontinuous at the origin and discontinuous at the origin because this modulus of x by x is discontinuous there. So clearly D is the correct answer because modulus of x by x is not continuous at the origin, as modulus of x by x is not defined at x is equal to 0. So you can observe here I have modulus of x by x is discontinuous at the origin because it takes 0 by 0 form. It takes 0 by 0 form. As x approaches to 0, modulus of x by x is 0 by 0. But if you take this mod x separately, it is continuous at the origin also. So clearly, as this is not defined, this function is not defined at x is equal to 0, as x approaches to 0, it is discontinuous at the origin. So wherever the function is not defined, it is discontinuous. So therefore option D is the right answer, as mod x by x takes the 0 by 0 form at the origin. Next, if f of x is equal to 1 minus cos x by x for x not equal to 0, k for x is equal to 0 is continuous at x equals 0, then k is equal to 0, 1 by 2, 1 by 4 and minus 1 by 2 are the 4 answers. So we can solve this by using the definition again. So limit as x tends to 0 because it is continuous at x equals 0. Therefore I am taking as limit as x approaches to 0 of 1 minus cos x by x is equal to k. See here, when you apply the limit, you will get 1 minus cos 0, which is 0. In the denominator also you will be having 0. So we can apply the formulas of the trigonometry, that is 1 minus cos x is 2 sin square x by 2 and divided by x and proceed. But instead I will apply L'Hopital's rule again. So which is a boon for us in solving such problems, L'Hopital's rule. So I will differentiate numerator, that is limit as x approaches to 0 of when you differentiate 1 minus cos x, you will get minus of minus sin x. Derivative of cos x is minus sin x. This you have learnt in first year itself. Derivative of 1 is 0. I have 1 minus sign here. Derivative of cos x is minus sin x and derivative of x is 1, which is equal to k. I have numerator as sin x now. So k is equal to sin x as x approaches to 0. So we know that it is sin 0, which is sin 0. When you apply the limit, it is sin 0, which is equal to k, which is 0. So k is equal to 0 is the correct answer. So for the function to be continuous, k must be equal to 0. So you can look another question. If f of x is equal to sine of 5x by x square plus 2x for x not equal to 0 and k plus 1 by 2 for x is equal to 0 is continuous at x equals 0, then value of k is option A is 2, option B is 1 by 2, and option C is 1, and option D is minus 4. So again we will use the definition. So we will apply the limit here as x approaches to 0, that is limit as x approaches to 0 of sine 5x divided by, I will take x common so that I have x plus 2 which is equal to k plus 1 by 2. So now this sine 5x by x, I will use this, I will multiply by 5 and divide this by 5 so that I can apply the theorem limit as x approaches to 0 of sine 5x by 5x into x plus 2. So as I have multiplied the denominator x by 5, I will multiply the numerator also by 5 so that the value will not change. On the right hand side I have k plus 1 by 2. So now the term inside the bracket becomes 2, that is sine 5x. See, you can observe sine 5x by 5x is 1. Limit as x tends to 0 of sine x by x is equal to 1. Therefore sine 5x by 5x is equal to 1. As x approaches to 0, I will get 2 inside this square bracket, and in the numerator I have 5. So I will get 5 by 2 is equal to k plus 1 by 2. So now you can easily solve this. That is k is equal to 5 by 2 minus 1 by 2. That is 5 minus 1 is 4 by 2, which is equal to 2. That is option A is the right answer. Option A is the correct answer for this question. Which of the following is not true always? So you can read the options carefully. If f of x is continuous at x equals a, then it is differentiable at x is equal to a. If f of x is not continuous at x equals a, then it is not differentiable at x equals a. If the function f of x is continuous at x equals a, then limit of f of x as x tends to a exists. If f of x and g of x are differentiable at x equals a, then f of x plus g of x is also differentiable. So let us come by one. Let us read the option A again. If f of x is continuous at x equals a, then it is differentiable at x is equal to a. So clearly we have seen in our NCERT textbook with an example also, and it is a property. Always differentiability implies continuity, but converse is not true. Differentiability implies continuity. That is, if a function is differentiable, then it is continuous, but the converse is not true. That is, if the function is continuous, we can't say that it is differentiable. So which of the following is not true always? It's not true always. So option A is the right answer. If the function is continuous at x equals a, then it is not differentiable at x equals a. Maybe sometimes true. If the f of x is not continuous, at x equals a, then it is not differentiable at x equals a is also always true. And if the function is continuous at x equals a, this limit exists. And if f and g are differentiable, then their sum is also differentiable. So option A is the right answer. You can remember this. Next, I have to find the points of discontinuity of f of x is equal to tan pi x by x plus 1. So we solved this question in a different way. So now we will solve this. I have to find the points of discontinuity. I have solved this by taking m is equal to 1. So we got the answer as x is equal to 2m plus 1 by 1 minus 2m, m belong to z. So here I will make an approach to this problem in a different way. That is, I have tan pi x by x plus 1. So I will consider this. This is not defined when pi x by x plus 1 is an odd multiple, that is 2m plus 1 into pi by 2. If tan of this angle is an odd multiple of pi by 2, then it is not defined. This becomes infinity. So that is, when you cancel pi here, you will get x by x plus 1 is equal to 2m plus 1 here. See, this implies I write pi and pi cancels. I have 2 here. I will write 2x here. So that you will get 2x is equal to 2mx. I will multiply plus 2m plus x plus 1 plus x plus 1. So you can cross multiply. So, and I will bring all the terms with x to one side. 2x minus 2mx is equal to, see, I have 2x minus x is x, and I have minus 2mx. X minus 2mx is equal to 2m plus 1, or if you take x common, you will get 1 minus 2m. Take the to right hand side denominator, you will get 1 minus 2m. So this is another approach to the same problem which we solved. So x is equal to 2m plus 1 by 1 minus 2m, m belongs to z. At this point, the given function is discontinuous because at x equals to m plus 1 by 1 minus 2m, tan theta is not defined. Tan theta is not defined. So here is a split function again. Let f of x is equal to minus 2 sin x for x less than or equal to minus pi by 2, a sin x plus b for x between minus pi by 2 to plus pi by 2, and cos x for x greater than or equal to pi by 2. Then the value of a and b, so that f of x is continuous r. So I have to find the value of a and b so that the function is continuous at minus pi by 2 as well as at x is equal to pi by 2. So now what we will do is, we will consider the left hand limit and right hand limit of the function at x is equal to pi by 2 and minus pi by 2 separately. First I will take the left hand limit. Left hand limit at x is equal to pi by 2, that is limit as x tends to, first I will take pi by 2 minus left hand limit. So pi by 2 minus is here, less than pi by 2, a sin x plus b, a sin x plus b, which is equal to, as x approaches to pi by 2, a sin pi by 2 is 1, so it is a plus b, and limit as x tends to pi by 2 plus, that is right hand limit. I have cos here, cos x, so this is cos pi by 2, cos x, which is cos pi by 2, cos pi by 2 is 0. So now the function to be continuous, we get a plus b is equal to 0. One equation I got, a plus b is equal to 0. If these two are same, then only the function is continuous. So a plus b is equal to 0. Next, let us look at minus pi by 2. So that is, I will take minus pi by 2 left hand limit and right hand limit here. I will erase this. That is limit as x tends to minus pi by 2 minus, that is left hand limit. See, I have here less than, x less than or equal to, I have minus 2 sin x. So it is minus 2 sin of minus pi by 2. Sin of minus pi by 2 is plus sin pi by 2, which is 1. So this becomes 2 here. As, and next I have limit as x tends to minus pi by 2 plus minus pi by 2 plus is here x greater than minus pi by 2. I have again a sin x plus b. When x is minus pi by 2, sin of minus pi by 2 is minus 1, so I will get a minus a plus b. So now I got another equation, minus a plus b is equal to 2. So we can solve this by using the simultaneous equation method. So if you add these two equations, you will get 2b is equal to a minus a is 0, 2b plus b is 2b is equal to 2, or b is equal to 1. So when b is equal to 1, I can use any equation to find a. So a will be minus 1. A will be minus 1. So that is, I have option C as the right answer. A equals minus 1 and b is equal to 1 is in option C. So I have applied the definition of continuity 2 times, that is at x equals minus pi by 2 once and x is equal to plus pi by 2 once. So we got the answer as option C. Here is one more question. Let f of x is equal to 1 minus tan x by 4x minus pi for x not equal to pi by 4. X belong to 0 to pi by 2 interval, closed interval 0 to pi by 2. F of x is continuous in closed interval 0 to pi by 2. Then what is the value of f of pi by 4? See, you can observe pi by 4 lies in this interval. So the function is continuous everywhere. So again I have to use the definition of continuity. I will use the definition of continuity, that is f of pi by 4 is the required value. To find f of pi by 4, I have to apply the limit as x tends to pi by 4 of 1 minus tan x divided by 4x minus pi here. F of pi by 4 is equal to limit as x tends to pi by 4 of 1 minus tan x by 4x minus pi. So as x approaches to pi by 4, both numerator and denominator will be 0, that is it takes 0 by 0 form. So what I will do, I will apply L'Hopital's rule. We will apply L'Hopital's rule. So f of pi by 4 is equal to limit as x tends to pi by 4 of 1 minus tan x, that is minus secant square x here. When you differentiate tan x, you will get secant square x. I have minus sign here. Derivative of 1 is 0. In the numerator, I will get 4 here. When x approaches to pi by 4, I will get secant pi by 4. Secant pi by 4 is root 2. So root 2 whole square. I will get root 2 whole square by 4. Root 2 whole square is 2. So I have 2 by 4, which is equal to 1 by 2. So option B is the right answer. Option B is the right answer for this question. So we are finding f of pi by 4. We applied the definition of continuity and then L'Hopital's rule here also. So all are almost similar problems based on the definition of continuity. So we will discuss questions on differentiability also. So we have another question. Consider f of x is equal to x square by modulus of x for x not equal to 0. F of 0 is equal to 0. That is, the value of f of x is 0 when x is equal to 0. So this is also actually a split function. It's like this. F of x is equal to x square by modulus of x for x not equal to 0, and it is equal to 0 for x is equal to 0. F of x is discontinuous everywhere. Option A is, it says it's discontinuous everywhere. F of x is continuous everywhere. F dash of exists in minus 1 and 1. F dash of exists in minus 2 and 2. So we know that modulus of x is not differentiable at x is equal to 0. So here in both the intervals 0 is included, and 0 by 0, that is f dash of f of x does not exist at 0, therefore f dash of x doesn't exist. So option C and option D are ruled out. So now I have two options to find, that is I have two choices. F of x is discontinuous everywhere or f of x is continuous everywhere. We have the definition of f of x is equal to mod x as it is minus x for x less than 0 and it is plus x for x greater than or equal to 0, or I can say minus x for x less than 0 and plus x for x greater than 0 and it is equal to 0 for x is equal to 0. Here x square by modulus of x is equal to x square by x, that is plus x, when for x greater than 0. So clearly this will be equal to, I will get x here. For x greater than 0, it is x means as this limit as extends to 0 plus becomes 0 here. Similarly, x square by modulus of x is equal to x square by minus x. So that will be minus x for x less than 0. This is also 0 at x is equal to 0. So I will get this as 0 in both the cases. Here it is minus x for x less than 0 and x greater than 0. So here this is an algebraic function, so or a polynomial function. I can say x square by mod x is equal to x is an polynomial function of degree 1, so it is clearly continuous for x greater than 0. X square by mod x for x less than 0 is minus x, again it is a polynomial function, hence it is continuous. Now at x is equal to 0, at x is equal to 0, x square by x is, at x equals 0 you will get x square by modulus of x is equal to x, which is 0 when x approaches to 0. Clearly it is continuous at x equals 0 also. Therefore f of x is continuous everywhere is the right answer. So option B is the correct answer. The function f of x is equal to sin 3x by x for x not equal to 0, k by x for x equals 0 is continuous at, it is continuous at x is equal to 0. Then k is equal to option A is 3, option B is 6 and option C is 9 and option D is equal to 12 here. So you can solve this by the definition again. So I will use the definition. So for the function to be continuous at x equals 0, limit of that function should be equal to the value of the function, that is limit as x approaches to 0 of f of x is equal to f of 0, that is limit as x tends to 0 of sin 3x by x is equal to k by x, it is k by x. This is what is given here. Okay, so it is actually k by 2. I am sorry, while typing it is typed as x, it is k by 2. So now limit as x tends to 0 of sin 3x by x is equal to k by 2. So now this implies we can rewrite this limit as x tends to 0 of sin 3x by 3x into 3, which is equal to k by 2. So we have this theorem, limit as x tends to 0 of sin x by x is equal to 1. So now the term inside this bracket is 1, so you will get 3 is equal to k by 2 or k is equal to 6. K is equal to 6 is the answer, which is in option B. Now I have another question. If f of x is equal to x square minus 10x plus 25 by x square minus 7x plus 10 for x not equal to 5 and f is continuous at x equals 5, then what is the value of f of 5 is the question. So f of x is continuous at x is equal to 5. The value of this function for x not equal to 5 is this one, and f is continuous at x equals 5. It is given that it is continuous at x equals 5. So therefore I can write this as f of 5 is equal to limit as x tends to 5 of x square minus 10x plus 25 divided by x square minus 7x plus 10 here. So this is equal to, as x approaches, limit as x approaches to 5 of x square minus 10x plus 25 by x square minus 7x plus 10 is equal to f of 5. This is what is required to find. So we will apply L'Hopital's rule, because you can observe this approaches 0 by 0 form when you apply the limit. That is, I have, you can note this, 5 square minus 50, 10 into 5 plus 25. So 25 plus 25 is 50 minus 50, 0. So here again 25 minus 35 plus 10. So when you apply the limit directly, it takes indeterminate form. So now I will apply L'Hopital's rule again to find f of 5. So now limit as x approaches to 5 of 2x, that is derivative of x square is 2x minus 10 here, divided by derivative of x square is 2x again minus 7 here. So when you apply the limit, numerator becomes 0. So let us not worry about denominator, which will be 10 minus 7, which will be 3. So answer is 0 for this. So f of 5 is 0 here again. F of 5 is 0. Next, if f from R to R defined by f of x is equal to a square cos square x plus b square sin square x for x less than or equal to 0, and e to the power of ax plus b for x greater than 0 is continuous function, then b is equal to 2 log a, 2b is equal to log a, or b, this is small b here, small b is equal to log 2a, or b square is equal to log a. So these are the 4 options here. So by data, f of x is continuous function, that is, it is continuous at x is equal to 0. Therefore again by definition, limit as x approaches to 0 of f of x is equal to f of 0 here. Now I have to consider 2 limits, that is left hand limit and right hand limit, because I have one value for x less than 0, another is x greater than 0, and at x is equal to 0, this is the value. I have to put x is equal to 0, that is f of 0 will be, I will write here, f of 0 will be, so you can observe cos 0 is 1, so I will get a square, and sin 0 is 0, so it is 0 here. So f of 0 is equal to a square actually. F of 0 is equal to a square. Now if I find the right hand limit, it is enough instead of left hand limit, because when you find the left hand limit also, you will get the a square only. So I will find x approaches to 0 plus, that is right hand limit, which will be e to the power of ax plus b, e to the power of ax plus b. So as x approaches to 0, it is e to the power of 0 plus b, which is equal to e to the power of b. Now e to the power of b is equal to a square, because for a function to be continuous, left hand limit is equal to right hand limit is equal to value of the function. So e to the power of b is equal to a square. To solve for b, I will take logarithm here. Logarithm of e to the power of b is equal to a square. We know that logarithm of e to the power of b is nothing but b log e, which is equal to a square. So log e is actually 1. On the right hand side, I have log a square here. It is log a square. I will made a mistake here while writing. I will correct it. So when left hand limit and right hand limit and the value of the function coincides, limit exists. Therefore a square, I will write from here, a square is equal to e to the power of b. So I will take log on both sides. Log a square is equal to log of e to the power of b. This implies log m to the power of k is k log m. So I have 2 log a is equal to b log e. B log e. So log e is 1. So 2 log a is equal to b, because logarithm of e to base e is 1. Logarithm of any number to its own base is 1, and if nothing is mentioned, when the base is not mentioned, you can consider it as base as e. Therefore log e is 1. Log e to base e is 1. So therefore b is equal to 2 log a. So option A is the right answer. Now if f of x is equal to root of 1 plus kx minus root of 1 minus kx by x for minus 1 less than or equal to x less than 0, 2x square plus 3x minus 2 for 0 less than or equal to x less than or equal to 1. So is continuous at x equals 0, it is given, then k is equal to, so I have to consider left hand limit and right hand limit. For x less than 0, the value of the function is root of 1 plus kx minus root of 1 minus kx by x. For x greater than 0, it is 2x square plus 3x minus 2. Again as usual, we will proceed by the definition, that is f of 0, that is when x is equal to 0, I have 2x square plus 3x minus 2. So that is 2 into 0 plus 3 into 0 minus 2. So here I have minus 2. So I got the value of the function, that is right hand limit and the value of the function will be same because they are continuous. Now I will evaluate left hand limit, that is as x approaches to 0 minus of this function, that is root of 1 plus kx minus root of 1 minus kx divided by x, so which is equal to minus 2, so which will be equal to minus 2. So we'll evaluate this. To solve this question, I have to rationalize the numerator now. So I will multiply and divide by root of 1 plus kx plus root of 1 minus kx. So you get limit as x tends to 0 of 1 plus kx minus of 1 minus kx. Root will be eliminated. A plus b into a minus b is a square minus b square. In the denominator, you will get root of x into root of 1 plus kx plus root of 1 minus kx. So this is equal to minus 2 actually, and now this plus kx minus into minus is plus kx again, so 2 kx, 1 and 1 will be eliminated. So you will get limit as x tends to 0 of 2 kx in the numerator. In the denominator, x into this thing, that is root of 1 plus kx plus root of 1 minus kx. X will be cancelled. On the right hand side I have minus 2. So here as x approaches to 0, denominator will be 2k, and in the numerator I have, if when this approaches to 0, kx is 0, root 1 plus root 1, so that is 2 here, which is equal to minus 2. 2 will be eliminated and k will be equal to minus 2. So k is minus 2, that is option C is the right answer. For the function to be continuous, the value of k should be minus 2. That is by rationalizing the numerator, you can evaluate the left hand limit, and value of the function, that is at x is equal to 0, it is 2x square plus 3x minus 2. I have taken it as minus 2 after solving this. So k will be minus 2. Now similar question, it is continuous at pi by 4. The given function f of x is equal to 1 minus root 2 sin x by pi minus 4x for x not equal to pi by 4. A for x equals pi by 4 is continuous at x equals pi by 4. Then a is equal to, so we will proceed in the similar manner by using the definition of continuity. So limit as x tends to pi by 4, because it's continuous at x equals pi by 4. I have 1 minus root 2 sin x by pi minus 4x is equal to value of the function, that is at x is equal to pi by 4, f of pi by 4, which is given as a here. So this implies limit as x tends to pi by 4 of, so you can notice here again, when you give when you give pi by 4 to x, that is when x approaches to pi by 4, sin pi by 4 is 1 by root 2. So numerator will be 1 minus 1 is 0. Here also 4 into pi by 4. 4 cancels, you will get pi minus pi 0. It takes 0 by 0 form again. So therefore as usual we will proceed with applying L'Hopital's rule. So I have derivative of 1 as 0 minus root 2 here, and cos x here. Derivative of sin x is cos x, and derivative of pi is 0, and I am left with minus 4 here. On the right hand side I have a. Now let us apply the limit. So you will get minus root 2 by minus 4, that is root 2 by 4 into cos pi by 4. Cos pi by 4 is equal to a here. Cos pi by 4 is 1 by root 2, so it is root 2 by 4 into cos pi by 4 is 1 by root 2, which is equal to a. So root 2 is eliminated, and a will be equal to 1 by 4. A equals 1 by 4. So option D is the right answer. So now I hope you are very much familiar with the problems on the continuity. So this helps you to score 4 marks in board examination also. So you can observe this question again. It is continuous at every point of its domain. Then the value of b is, so I have f of x as 5x minus 4 from 0 to 1, and 4x square plus 3bx from 1 to 2. That is when x lies between 1 and 2, you will get the value as 4x square plus 3bx, and when x lies between 0 and 1, you have 5x minus 4. So I will proceed by using the definition of continuity again. So that is limit as x tends to 1 minus is 5x minus 4, that is when x is less than 1, I have 5x minus 4. So therefore limit as x tends to 1 minus of 5x minus 4 is equal to, as x approaches to 1, you will get 5 minus 4, which is equal to 1 here. And let us evaluate right hand limit, that is 1 plus is equal to 4x square plus 3bx, which is equal to, as x approaches to 1, I have 4 plus 3b here. So I have to find the value of b. So it is continuous, therefore left hand limit and right hand limit are same. So 4 plus 3b is equal to 1, or 3b is equal to 1 minus 4 is minus 3, or b is equal to minus 1, which is in option A, here. Next, the value of f of x at x is equal to 0, so that the function f of x is equal to 2 to the power of x minus 2 to the power of minus x for x not equal to 0 is continuous at x equals 0. Option A is 0, option B is log 2, option C is 4, and option D is log 4. So the value of f of x at x equals 0, that means I have to find f of 0 again. So to find f of 0, I have to consider the limit as usual, that is the definition of the continuity. Limit as x approaches to 0 of 2 to the power of x minus 2 to the power of minus x divided by x is equal to f of 0. This is what is required to find. As x approaches to 0, you can observe it is 2 to the power of 0 minus 2 to the power of minus 0 by 0, which is 1 minus 1 again, 0 by 0 form, indeterminate form. So you can easily, clearly apply L'Hopital's rule. When you differentiate 2 to the power of x, you will get 2 to the power of x into log 2, that is limit as x approaches to 0 of derivative of a to the power of x. Derivative of a to the power of x is a to the power of x into log a. So therefore derivative of 2 to the power of x is 2 to the power of x into log 2 minus here 2 to the power of minus x. Derivative of 2 to the power of minus x is 2 to the power of minus x into log 2 into derivative of minus x is minus 1. So this becomes plus divided by 1, which is equal to f of 0 here. So now apply the limit to as x approaches to 0, 2 to the power of x becomes 1. Here also 2 to the power of minus x becomes 1. Therefore you will get log 2 plus log 2 is equal to f of 0. Log 2 plus log 2 is 2 log 2, which is f of 0, or log, this is nothing but log 2 square, because k log m is log m to the power of k. Log 2 square is equal to f of 0. Log 2 square is log 4. So log 4 is in option D here. So here is the answer, log 4, which is in option D. So here also we applied L'Hopital's rule and the definition of continuity. The function f of x is equal to log of 1 plus ax minus log of 1 minus bx by x is not defined at x equals 0. The value which should be assigned to f at x equals 0 so that it is continuous at x equals 0. We solved a very similar question, but it is asked in a different way. We know that it has a removable discontinuity. Where that is when we define f as f of 0 as a plus b, then it will be continuous. So you can apply L'Hopital's rule. I have done this problem, that is 1 by a plus x into a minus 1 by 1 minus bx into minus b, as limit as x approaches to 0 here by 1. So by giving the value to x, you will get a plus b. This we have seen, so I will not discuss this again. So the same question is asked in a different way here. So answer is a plus b. Next, the function f of x is equal to greatest integer x, where greatest integer x denotes the greatest integer not greater than x is continuous only at rational values of x, continuous for all real values of x, continuous only at positive integral values of x, continuous for all non-integral values of x. So you can recall the graph. You can recall the graph of this function, which we studied in first year, relations and functions. So the graph of this will be like this. It's a step function. So when there is a break in the graph, then the function is not continuous. When there is no break, that is a function is a smooth curve, then it is a continuous function. So this is the graph of the what I have shown on the screen is a graph of this greatest integer function. So it is discontinuous at integral non-integral values. It is continuous at integral values. See, clearly f of x is equal to greatest integer x is continuous for all non-integral values. See here 0 to 1, 1 to 2, 2 to 3, 3 to 4, like this. At the non-integral values of x it is continuous, at integral values it is discontinuous. So continuous for all non-integral values, because you know that it is, if you write 2.1 you will be getting 2 here, if you get 2.3 you will get 2 here, when it is 2.99 also it is 2. So when it is 3 point something, or when it approaches to 3 you will get 3. So there will be a difference here. So there is a break in the graph clearly. It is continuous for all non-integral values, and it is discontinuous at the integral points. You can remember this point, and there is a problem in NCERT book also. Hope you have solved this. Okay, thank you. I will conclude this session here. So in the next video we will discuss the differentiability question. So in this video I have discussed only the problems on continuity, as I heard that up to this only the portion has been covered. I have chosen the questions on continuity only. Thank you. Hope you are following. In case of any doubts, certainly you can approach me and you can give your feedback, so that I will try to give my best to you. Thank you.